So as mentioned in the email this video is attached to, in a trip from Killarney to Cork, Charlotte and Shauna drive 27 degrees west of south for 18 kilometers to Kinmare, then directly south for 17 kilometers to Glengariff, then 13 degrees north of east for 48 kilometers to Cork. What are the magnitude and direction of the displacement vector for the entire trip? Well, we can call the four positions R1 for Killarney, R2 for Kinmare, R3 for Glengariff, and R4 for Cork. So the displacement for the whole trip is going to be R4 minus R1. And in this problem, they give us the displacements for the three parts of the trip. And to kind of make things a little easier to see, I just used the A vector, B vector, and C vector for the three displacements. So the A vector is equal to R2 minus R1, which is equal to 18 kilometers, 27 degrees west of south. The B vector is equal to R3 minus R2, which is equal to 17 kilometers south. And the C vector is equal to R4 minus R3, which is 48 kilometers, 13 degrees north of east. Now the sum of these three displacements is the total displacement. So up here I have written out the graph for which they travel, and I used a conventional choice for the x-axis and y-axis, and I showed that the first displacement, the A vector, is directed 27 degrees west of south, and both of its components are negative, since west is in the negative x direction and south is in the negative y direction. And using this, I was able to obtain the equation here, which was that A in the x direction is equal to negative A sine 27 degrees, and all I did was put my values in for that, and I get that it's negative 8.17 kilometers. And then A in the y direction is going to be negative A cosine of 27 degrees, and all I did again was put my values in for that, and I get that out to be negative 16 kilometers. And the displacement for the B vector has no component since its direction is south, so therefore the Bx is equal to 0, and By is equal to negative 17 degrees. And now the direction of the C vector is 13 degrees north of east, so both of its components are positive. And to see this, I use the equation here, which is C sub x is equal to positive C cosine of 13 degrees. And I plug my values in for that, and I get it out to be positive 46.8 kilometers. And then for the CY, I've used the formula of positive C sine of 13 degrees. And again, plug my values in, and I get that out to be as positive 10.8 kilometers. And now we can sum the x and y components separately to find the x and the y components of the total displacement. And we do that by using the equation of the change in x is equal to ax plus bx plus cx. And after plugging my values in for that, I get that out to be 38.63 kilometers. And then we do the same thing for y, as do the change in y is equal to ay plus by plus cy. And again, plug the values in, and I got negative 22.2 kilometers for that. And now the magnitude and direction of the change in r are found using this equation here, which is the change in r is equal to the square root of the change in x squared plus the change in y squared. And all I did was put my values in for that, and I got that out to be 45 kilometers. And to find the angle, I use the equation of theta is equal to the inverse tangent function, which is opposite over adjacent. And I plug my values in for that, and I get that as 30 degrees. So the magnitude and direction of the displacement vector for the entire trip is going to be 45 kilometers at 30 degrees.